superposition works only for linear circuits. The idea is simple. Keep one independent source active, deactivate all the other independent sources, find that source's contribution, and then add the contributions. When we deactivate an ideal voltage source, we replace it by a short circuit. When we deactivate an ideal current source, we replace it by an open circuit. Dependent sources, if present, are not turned off, but this example has only independent sources. In the worked example, we need the downward current I through the 12 kOhm resistor. There are three independent sources, a 30 mA current source on the left, a 15 mA current source on the top branch, and a 15-volt voltage source in series with the 4 kOhm resistor. So we will write I equals I1 plus I2 plus I3, where each term is the contribution of one active source. First, keep only the 30 mA source active. The 15 mA source becomes an open circuit, and the 15-volt source becomes a short circuit. The right side 12 kOhm and 6 kOhm resistors are in parallel, so their equivalent is 4 kOhms. That is in series with the 4 kOhm resistor, making an 8 kOhm path. This 8 kOhm path is in parallel with the 2 kOhm resistor. By current division, the current in the 8 kOhm path is 6 mA. Then that current divides between 12 kOhms and 6 kOhms, giving I1 equals 2 mA downward. Second, keep only the 15 mA source active. The left 30 mA source is opened, and the 15-volt source is shorted. Between the two top nodes, the direct 4 kOhm branch is in parallel with the lower path made of 2 kOhms plus the parallel combination of 12 kOhms and 6 kOhms. That lower path is 6 kOhms. Current division sends 3 mA into the lower path, and the 12 kOhm branch receives 2 mA. So the second contribution is I2 equals 2 mA downward. Third, keep only the 15-volt source active. Both current sources are opened. The 12 kOhm and 6 kOhm resistors are again equivalent to 4 kOhms. So the loop resistance is 4 kOhms plus 2 kOhms plus 4 kOhms or 10 kOhms. The loop current is 15 volts divided by 10 kOhms, which is 1.5 milliamps. That current makes the 12 kOhm branch current point upward, opposite to our reference direction. Therefore, I3 equals negative 0.5 milliamps. Now add the three contributions with signs. The total current is 2 milliamps plus 2 milliamps minus 0.5 milliamps. Therefore, the requested current is 3.5 milliamps downward. The important habit is to keep the reference direction fixed from the beginning. A negative contribution is not a mistake. It simply means that source pushes current opposite to the chosen reference.